You're standing at the edge of the water. The surface is warm. The sunlight reaches your skin. You can see the bottom. Everything feels safe. Now imagine walking forward. Not across the ocean floor, but straight down, into it, 1 meter at a time. The light dims. The temperature drops. The weight of the water above you begins to press against your chest. At 10 meters, the pressure has already doubled. At 100 meters, your lungs would compress to the size of a fist. At 200 meters, the last trace of sunlight disappears. And you still have nearly 11 kilometers left to go. The ocean is not one environment, it's 5, stacked on top of each other, each one more hostile than the last. 5 layers separated by physics, by light, by pressure, and by what life has to become in order to survive there. We've mapped the surface of Mars in higher resolution than we've mapped our own sea floor. We've sent more people to the moon than we've sent to the deepest point in the ocean. And more than 80% of what lies beneath the waves has never been seen by human eyes. This isn't a nature documentary, this is a descent, and each layer down is worse than the one before. The first 200 meters of ocean are everything we recognize. This is where sunlight penetrates, where photosynthesis fuels an entire food web, where coral reefs bloom, and whales breach, and schools of fish scatter in the sun. 90% of all marine life lives in this thin upper layer. It is the engine of the ocean, the foundation of everything below. But don't mistake familiarity for safety. The sunlight zone is the most violent place in the sea. This is where predation is constant, where everything can see everything, and where there is nowhere to hide. Great whites patrol, detecting a single drop of blood from a quarter mile away. Orcas hunt in coordinated packs, creating waves to wash seals off ice floes, ramming great whites from below to paralyze them, teaching their calves to hunt by sharing live prey. Barracuda slash through schools of fish at 36 miles per hour. Jellyfish drift in swarms, trailing venomous tentacles that can stop a human heart. Box jellyfish alone kill more people annually than sharks, crocodiles, and stonefish combined. The sunlight zone is also where the ocean disguises its most lethal mechanisms in beauty. Blue-ringed octopuses, small enough to sit in your palm, carry enough venom to kill 26 adults within minutes. There is no antivenom. Cone snails fire hollow, harpoon-like teeth, loaded with a cocktail of neurotoxins so complex that pharmaceutical companies study them for painkiller development. Stonefish lie camouflaged on the seafloor, their dorsal spines delivering pain so severe that victims have begged for amputation. And beneath the surface calm, there's a war of chemistry. Phytoplankton, microscopic plants no bigger than a human hair, produce roughly 50% of the oxygen on Earth, more than all the forests combined. They feed everything from krill to blue whales. But they're also dying. Ocean warming, acidification, and nutrient runoff are disrupting the blooms that fuel the entire system. If the sunlight zone falters, so does the oxygen supply for the planet. Not eventually, within decades. The surface is the one zone we can survive in. It's also the one we're destroying fastest. At 200 meters, the light doesn't vanish all at once. It fades. Blue-green wavelengths stretch the deepest, painting everything in a dim, ghostly hue, before that, too, disappears. By 500 meters, photosynthesis is impossible. By 1000, the last photon of sunlight has been absorbed. You are now in the twilight zone. The pressure here is 100 atmospheres. That's 1,470 pounds per square inch, pressing against every surface of your body. For context, an inflated car tire holds about 30 psi. You're now under 50 times that. An unprotected human body wouldn't just be uncomfortable here, it would be physically compressed. Lungs would collapse, sinuses would implode, eardrums would rupture long before you reach this depth. And yet, this zone is alive, staggeringly alive. Scientists estimate the Twilight Zone contains more fish biomass than the rest of the ocean combined. Billions upon billions of organisms live here. Feeding on the slow rain of dead material drifting down from above. Scientists call it marine snow. Fragments of plankton, fecal matter, dead cells, the decomposing remains of the sunlit world, sinking into the dark. It sounds insignificant. To the creatures here, it is everything. Many animals in this zone are transparent. Glass squid drift with organs barely visible. Glass octopuses are almost invisible, their eyes the only solid feature. Others use bioluminescence, manufacturing their own light through chemical reactions to hunt, communicate, and hide. The firefly squid covers its belly in light-producing organs, matching the faint glow from above to erase its silhouette from predators below. It makes light to disappear into light. But the most extraordinary thing happening here is invisible to the eye. Every night, as darkness falls above, billions of creatures rise from the Twilight Zone toward the surface to feed on plankton. At dawn, they sink back down. This is the diel vertical migration, the largest synchronized animal movement on Earth. Greater in sheer biomass than every herd, every flock, every swarm on land combined. And it remained entirely unknown until World War II, when naval sonar operators detected a mysterious false seabed that rose every night and sank every morning. It wasn't geology, it was life. An entire hidden world, breathing in rhythm with the sun. The Twilight Zone is where the rules of the surface begin to break down, and below it, they shatter completely. Below 1,000 meters, all sunlight is gone. Not dim, not faint, gone. You are now in permanent, absolute darkness. The temperature hovers between 1 and 4 degrees Celsius, just above freezing. The pressure is between 100 and 400 atmospheres. At the lower boundary of this zone, 4,000 meters down, the weight on every square inch of your body would be approximately 5,880 pounds. That's nearly 3 tons pressing on an area the size of a postage stamp. No human has ever been exposed to this pressure unprotected. No human ever could be. At this depth, the hull of a recreational submarine would crumple like aluminum foil. Military submarines have crush depths far shallower than this. The USS Thresher, a nuclear-powered attack submarine, imploded at roughly 730 meters in 1963, killing all 129 people aboard. That was barely into the midnight zone. The pressure at 4,000 meters is 5 times greater than what destroyed the Thresher. In 2023, the submersible Titan, operated by OceanGate, suffered a catastrophic implosion at roughly 3,800 meters while descending toward the Titanic wreck. The water pressure at that depth, roughly 400 atmospheres, crushed the vessel so fast that the occupants had no time to register what was happening. The force was equivalent to the weight of the Eiffel Tower pressing on the hull. The implosion happened in milliseconds, not seconds, milliseconds. And yet, life thrives here, not in spite of the conditions, but because of them. The Midnight Zone is where evolution turns desperate, where the rules of the surface don't apply, and biology reaches for solutions that seem more like science fiction than science. The anglerfish dangles a bioluminescent lure from its forehead, drawing prey into its jaws in total darkness. Its reproductive strategy is one of the most extreme in the animal kingdom. Males are born tiny and nearly blind. Their sole purpose is to find a female. When one does, he bites into her flesh, fusing his body to hers. His organs dissolve. His circulatory system merges with hers. He becomes a permanent parasitic sac of sperm, living off her blood for the rest of his life. Other predators here are draped in ultra-black skin, so efficient at absorbing light that they reflect less than 0.5% of what touches them. Even when a submarine spotlight hits them directly, they nearly vanish. The dragonfish produces red bioluminescence, a wavelength invisible to almost every other animal in the deep. It hunts with a private searchlight, seeing prey that can't see the light illuminating them. The Midnight Zone is a world of ambush, patience, and grotesque adaptation. Food is scarce, energy is precious, every calorie must be earned, and nothing is wasted. The black swallower can consume prey over twice its own length and 10 times its mass by distending its stomach into a translucent balloon. It literally eats animals larger than itself, digesting them over days while hanging motionless in the dark, its prey visible through the stretched stomach wall. Some specimens have been found dead at the surface because the meal was so large it began decomposing before it could be digested, the gases of decay inflating the stomach and dragging the swallower upward to its death. Even eating can kill you here. Animals in this zone grow slowly, reproduce rarely, and can live for extraordinary spans of time. The Greenland shark, which prowls these depths, may live over 400 years, the longest known lifespan of any vertebrate. Time itself moves differently down here. And this is also where the great battle takes place, the one humans have never witnessed. Sperm whales dive to these depths dozens of times a day, slowing their hearts from 60 beats per minute to 10. Collapsing their lungs, and firing sonar clicks at 230 decibels to hunt giant squid in total blackness. The squid, deaf to the whale's sonar, relies on basketball-sized eyes to detect the faint bioluminescent glow the whale leaves in its wake. Two apex animals, each engineered for the midnight zone, locked in a predator-prey arms race that has been running for tens of millions of years. And we know it only from the scars they leave on each other's bodies. Below 4,000 meters, the ocean floor begins, and it is vast. The abyssal plains cover more than half the surface of the planet, more territory than all forests, grasslands, and deserts on land combined. And yet they are among the least explored places on Earth. The pressure here ranges from 400 to 600 atmospheres. Temperature never rises above 4 degrees Celsius. There is no light, no current to speak of, no landmarks. Just an endless desert of fine silt stretching in every direction. If you could stand on the abyssal plain and look around, you would see nothing. Not because your eyes had failed, but because there is nothing to see. No coral, no kelp, no structure, just mud. Soft, ancient, featureless mud, accumulating at a rate of about 1 centimeter per 1,000 years. The silence here is absolute. No waves, no wind, no distant hum of life. Sound travels far in deep water, but here there is almost nothing making it. This is the closest thing on Earth to the void of space. And yet, even here, life persists. Giant isopods the size of footballs scuttle across the sediment. They are scavengers, waiting for the rare windfall of a dead body sinking from above. Amphipods, normally tiny, can grow longer than a human hand, a phenomenon called deep-sea gigantism that scientists still can't fully explain. Some hypothesize it relates to metabolic efficiency in the cold. Others suggest it's a defense against the few predators that exist. The honest answer is, we don't know. The most dramatic event in the abyss is a whale fall. When a dead whale sinks to the bottom, it becomes an oasis. A single carcass can feed an entire ecosystem for decades. Scavengers arrive first. Hagfish, sleeper sharks, crabs, stripping the flesh. Then come the specialists. Bone-eating worms called ossidacs colonize the skeleton, feeding on oils locked inside the bones. Bacterial mats bloom. Entire communities spring up on a single body, thriving in the dark long after the animal that created them has been consumed.
One whale fall, decades of life.
In the abyss, death doesn't end, it transforms. And then there's the vampire squid. Despite its terrifying name, it's not a predator at all. It drifts through the deep, collecting particles of marine snow on long, sticky filaments. It lives in oxygen minimum zones where most animals would suffocate, surviving on a blood pigment with the highest oxygen affinity of any known cephalopod. It doesn't hunt, it doesn't chase, it simply waits in the dark, catching the dead remains of the world above. A garbage collector of the abyss, thriving where almost nothing else can breathe. Below 6,000 meters, you leave the ocean floor and enter the trenches. These are the scars of the Earth itself, places where one tectonic plate slides beneath another, dragging the ocean floor down into chasms so deep they seem almost geological errors. This is the Hadal Zone, named after Hades, the underworld. The deepest known point on Earth is Challenger Deep in the Mariana Trench, nearly 11,000 meters below the surface. If you dropped Mount Everest into it, the summit would still be more than a mile underwater. The pressure at the bottom of Challenger Deep exceeds 1,000 atmospheres, over 16,000 pounds per square inch, 8 tons pressing on every square inch of surface. To put that in terms the body understands, it would be like balancing 50 jumbo jets on top of a single person. A human body at this depth would not just die, it would cease to exist as a recognizable structure. Bones would fragment, tissues would compress to a fraction of their volume. The physics of the Hadal Zone don't just kill you, they erase you. Only 28 people have ever reached Challenger Deep. Fewer than have walked on the moon. The first were Jacques Piccard and Don Walsh in 1960, descending in the bathyscaphe Trieste. It took them nearly 5 hours to reach the bottom. They spent 20 minutes on the seafloor before a cracking viewport forced them to surface. For the next 52 years, no human returned. Then, filmmaker James Cameron made the first solo descent in 2012, spending over 2 hours motoring slowly across the bottom, filming and photographing a world no one had seen in half a century. He described it as barren, flat, and eerily still. And in 2019, explorer Victor Vescovo reached a measured depth of 10,925 meters and made multiple return dives, proving the technology could work repeatedly. On one dive, his team sent a polystyrene cup down with a submersible. At the surface, it was the size of a normal drinking cup. At the bottom of Challenger Deep, the pressure had crushed it to the size of a shot glass. Every air pocket compressed, every molecule forced closer together. That's what 1,000 atmospheres does to foam. Imagine what it does to a lung. Vescovo described the bottom as flat, beige, covered in thick silt. Quiet, peaceful, and alive. Because life is here. Even here, Hadal snailfish, translucent and gelatinous, with no rigid bones, and cell membranes reinforced with specialized molecules that keep proteins functioning under pressures that would destroy any surface organism. They are the deepest living vertebrates ever discovered. Amphipods swarm across the trench floor in huge numbers. Recent studies found microplastic fibers inside their bodies, proof that human pollution has reached the most remote habitat on the planet. Even in the underworld, we have left our mark. At hydrothermal vents along trench walls, life takes an even stranger turn. Microbes feed not on sunlight or marine snow, but on chemicals erupting from the Earth's crust. Hydrogen sulfide, methane, dissolved metals in superheated water. Entire communities of tube worms, clams, and crabs depend on these chemical pioneers. It is a food web powered by geology, not biology. Chemosynthesis instead of photosynthesis. Life that doesn't need the sun. Life that runs on the planet itself. These discoveries rewrite what we think is possible. If organisms can thrive in conditions this extreme, feeding on chemistry in total darkness under crushing pressure, then the icy moons of Jupiter and Saturn, Europa and Enceladus, with their subsurface oceans warmed by tidal forces, are no longer theoretical candidates for life. They are plausible ones. Studying the Hadal Zone isn't just oceanography, it's astrobiology. Here's what stays with me. The ocean is not one place. It is 5 concentric nightmares stacked on top of each other. Each one removes something the layer above provided. The sunlight zone gives you light, warmth, food, and visibility. The twilight zone takes the light. The midnight zone takes the warmth. The abyss takes the food. And the Hadal Zone takes any remaining illusion that you belong there. Every layer down is a new test. A new set of physics designed to kill anything that hasn't evolved specifically to endure it. And at every layer, life has answered. Not with retreat, but with reinvention. Transparent bodies, bioluminescent camouflage, parasitic reproduction, ultra-black skin, ammonia buoyancy, bone-eating worms, chemosynthetic ecosystems that run on volcanic chemistry. We've mapped 5% of the ocean floor in high resolution. 5%. The rest is a blank. The largest habitat on Earth, covering more area than every continent combined, and we have explored less of it than the surface of the moon. The deepest places on this planet are not relics, they're not empty graves. They are thriving alien worlds that have been operating in total darkness for hundreds of millions of years, long before we existed, and they will persist long after we're gone. We didn't discover the deep ocean. We just finally noticed it was there. And every time we send a camera down, every time a submersible touches the bottom of a trench or a drone sweeps across an abyssal plain, we find something we didn't expect. A new species, a new adaptation, a new reminder that the most terrifying place on Earth isn't a desert or a volcano or the vacuum of space. It's the water beneath your feet, and it goes down a lot further than you think.